希望广大文艺工作者不忘初心，牢记使命，不负时代，不负人民。
When Xi Jinping speaks of national rejuvenation and China's unstoppable rise, he's not just invoking ideology. His policies speak for themselves. Xi Jinping is right to claim that Chinese-made giant construction machines are the reason why China can destroy and build anything. These aren't sci-fi fantasies or distant prototypes. They're real-world engineering behemoths reshaping landscapes at a pace the world has never seen. From terraforming the South China Sea with dredging giants to threading high-speed railways through the Himalayas with tunnel-boring titans, these colossal machines are the steel sinew behind China's explosive growth and the silent threat beneath its growing geopolitical might. You're going to be shocked through and through. Let's get started. Number 10. SLJ 900-32, the Iron Monster. Nicknamed the Iron Monster, the SLJ 900-32 is China's answer to decades of sluggish infrastructure development, not just at home, but across the globe. At first glance, it looks like a metallic centipede from a sci-fi movie. 580 tons of raw engineering muscle stretching 91 meters long, with 64 independently rotating wheels and the ability to walk across concrete pylons like it's out for a casual stroll. But this isn't some oversized toy. It's one of the most advanced bridge-building machines in the world, and one of the few that doesn't need to be dismantled and rebuilt section by section like its Western counterparts. Instead, it moves autonomously from one section of an elevated highway to the next, lifting and placing prefabricated bridge spans with millimeter precision. Unlike in the US, where building a single overpass can take years due to red tape, labor shortages and outdated machinery, the SLJ 900-32 can install a full bridge span every 24 minutes. Yes, you heard that right. Every 24 minutes, it lifts, aligns, and places a 700-ton span of concrete and steel into place, then moves on to the next one like it's flipping pages in a book. And it doesn't even need a crane. It lifts the spans itself, maneuvers into position, and places them with the kind of surgical accuracy you'd expect from a robotic arm in a high-tech factory, not a 580-ton machine hovering 30 meters above a river gorge. Its most iconic deployments have been in high-altitude terrains and densely populated urban zones, where conventional construction would grind to a halt. It's been instrumental in building sections of the Beijing-Xiong'an intercity railway and the mountainous stretches of highways in Yunnan and Sichuan, where cranes are often useless due to steep gradients and unstable ground. But the SLJ 900-32 doesn't care. It brings the bridge with it, moves itself forward, and repeats the process. It's a bridge-building factory on legs. What makes this monster truly world-class, though, isn't just its speed, it's its independence. Most bridge construction worldwide relies on multiple machines working in sync. Cranes, transporters, scaffolding rigs, and a whole army of human operators. But the SLJ 900-32 is a one-machine show. It lifts the beam, carries it to where it needs to go, positions it perfectly, and sets it down, all by itself. It's designed for speed, safety, and scale, and the Chinese government has already deployed multiple versions of it both domestically and in overseas projects tied to the Belt and Road Initiative. Impressive, right? Well, there's a lot more from where that came. Number 9. Tiankun, the Magic Island Maker. They call it the Magic Island Maker, but the Tiankun is less magic and more mechanical sorcery. At 140 meters long and boasting a dredging capacity of 6,000 cubic meters per hour, this steel leviathan manufactures land out of nothing, turning the open ocean into concrete-forward geopolitical real estate. Engineered by China's Tianjin Dredging Company, Tiankun is the largest and most powerful cutter suction dredger ever built in Asia, and arguably the world. Designed to carve through coral, clay, silt, and even rock, It operates like a surgical drill powered by sheer brute force. Its massive cutterhead, positioned on a long, extendable boom, tears up seabeds while high-powered pumps suck in slurry and sediment. That slurry is then pumped through pipelines, sometimes up to 15 kilometers long, to reclaim land elsewhere. The result? Entire islands rising out of the sea in months. The Magic Island maker has already made its mark across the South China Sea. The Spratly Islands, once little more than scattered coral atolls, are now home to full-blown airstrips, radar towers, and deep-water ports, thanks in large part to the Tiankun Hao and its predecessor, the Tianjing Hao. This newer vessel is exponentially faster and more versatile, capable of operating in deeper waters and tougher sediment. It doesn't just dredge, it terraforms. And when it's done, you don't just have more land, you have strategic control. The ship's ability to pump thousands of cubic meters of seabed material around the clock allows it to transform a reef into an artificial island large enough for military-grade airstrips and facilities within just a few months. And this is no exaggeration. Satellite images have confirmed the transformation of several reefs into fully operational bases in record time. While critics argue about the legality and environmental impact, one thing is clear: China is playing chess, not checkers. And this machine is its queen. In contrast, the US Navy doesn't possess any equivalent dredger of this scale or speed, and its island-building capacity is almost non-existent outside of small-scale port maintenance or beach replenishment projects. European countries like the Netherlands and Belgium do have advanced dredging fleets. After all, they've been reclaiming land from the sea for centuries, but even they have not combined this level of dredging power with geopolitical strategy on such a massive, coordinated scale. The Tiankun Hao is a piece of hardware executing a much larger vision. While Western navies rely on carrier groups and forward bases built decades ago, China is literally creating new strongholds on demand. What sets this beast apart isn't just the tech, it's what it represents. The Tiankun Hao is part of a new playbook, where influence isn't just projected with ships and missiles, but with land itself. And if you control the land, you control the airspace, the waters, the trade routes, the rules. Number 8. Kunlun Bridge Building Machine. Weighing in at a jaw-dropping 967 tons, the Kunlun Bridge Building Machine is the lifeblood of China's high-speed rail revolution. Designed to lift and precisely place girders weighing up to 1,000 tons each, the Kunlun assembles the backbone of a nation racing ahead at bullet train velocity. Named after the legendary Kunlun Mountains, which in Chinese mythology are the home of gods and immortals, the machine lives up to its namesake. This isn't just about size, it's about scale, speed, and purpose. China's high-speed rail network currently stretches more than 40,000 kilometers, making it the longest in the world by far. In contrast, the United States, a country of comparable geographic size, has a paltry 735 kilometers of high-speed rail, most of it crawling along at outdated definitions of high speed. That disparity didn't happen by accident. It happened because of machines like Kunlun. The Kunlun operates with extraordinary precision. Its core function is to lay pre-assembled bridge girders across wide spans, whether over valleys, rivers, or roads, without needing cranes, scaffolding, or massive external support systems. The girder is lifted, balanced, and positioned with surgical control, despite weighing more than a commercial jet. With each motion, Kunlun advances a few meters, carrying and installing its massive load like it's nothing more than a plank of wood. But what it's really doing is enabling China's trains to glide over impossible landscapes at over 300 kilometers per hour. The logistics alone are staggering. Without machines like Kunlun, building elevated tracks across rugged regions or dense urban areas would be a nightmare of cranes, road closures, and manpower. But with Kunlun, the process is fast, streamlined, and repeatable. And that's the real secret: repeatability. China isn't just building one showpiece bridge or one signature rail line. It's replicating world-class infrastructure at scale, mile after mile, province after province. The Kunlun machine, therefore, isn't just building bridges, it's building momentum. Number 7. CRCHI tunneling machine. The CRCHI tunneling machine is no ordinary piece of engineering. It's a 15-meter-wide subterranean titan powered by an astonishing 9,755 kilowatts of energy. Built by China Railway Construction Heavy Industry Corporation, or CRCHI, this tunnel boring machine, or TBM, doesn't just cut through rock. It carves pathways through geological nightmares, turning once impossible infrastructure dreams into steel-lined, high-speed corridors. One of its crowning assignments, the legendary Sichuan-Tibet Railway. This is not your average rail line. It's a high-stakes mega-project winding through the Himalayas, one of the most geologically unstable, seismically active, and altitude-hostile regions on the planet. To conquer this terrain, China needed more than manpower. It needed a machine that could withstand everything from hard granite to landslide-prone sediment. And that's where the CRCHI TBM shines. What makes this machine so formidable is not just its size or power, it's its precision. Unlike traditional explosives-based tunneling, which is messy, dangerous, and often structurally unstable, the TBM cuts in a controlled, continuous motion. It bores forward like a mechanical earthworm, supported by a tail of segment-laying arms that install reinforced concrete rings as it advances. Every centimeter of progress is reinforced, sealed, and prepped for track laying behind it. And the best part? It works 24/7, regardless of weather, altitude, or temperature. To put its size into perspective, the machine is wide enough to fit a 5-lane highway inside its bore. It creates space for not just high-speed rail lines, but also emergency access tunnels, cable systems, drainage routes, and ventilation. That's critical in high-altitude projects like the Sichuan-Tibet line, where human labor is limited by oxygen levels, and manual excavation would take decades, or be outright impossible. The West has its own TBMs, of course, machines like Bertha in Seattle or the Crossrail TBMs used in London, but none compare to the scale, ambition, and frequency of use seen in China. Bertha, for instance, famously stalled for months during the Seattle tunnel dig due to mechanical failures and unexpected obstacles. China's CRCHI machines, on the other hand, are not designed for showpiece projects, but are mass-deployed across the nation, used to carve highways, metro systems, water tunnels, and cross-border high-speed rail arteries. While Western nations debate and delay underground projects due to cost and complexity, China is already boring the next tunnel before the current one is even completed. Number 6. CPG 500 Railway Construction Machine. If you've ever wondered how China managed to stitch together the world's most extensive high-speed rail network, over 40,000 kilometers and counting, look no further than the CPG 500. Clocking in at over 2 kilometers of track laid per day, the CPG 500 isn't just building railways, it's outpacing the rest of the world's infrastructure timelines by years. At first glance, the CPG 500 doesn't look like a flashy piece of hardware. There are no massive arms swinging steel beams or spinning wheels chewing through rock. But make no mistake, this machine is a silent, unstoppable conveyor of national ambition. Every morning it wakes up, moves forward on the tracks it just laid, and begins placing more rails and sleepers with absolute precision. It's a continuous ballet of alignment, calibration, and welding. And that's how you get a nation connected via railroads. What makes the CPG 500 so revolutionary is its integration of multiple phases of rail construction into one seamless operation. In the past, laying high-speed rail required multiple teams of machines to work in sequence: foundation, ballast, sleepers, rails, welding, and inspection. Each step was separate, with the potential for delays or errors. The CPG 500 changed the game by combining these into a single synchronized system. Think of it as a moving rail factory, laying flawless track with machine-like consistency and human oversight only for quality control. And the quality is near perfect. China's high-speed rail doesn't just boast length, it boasts performance. Trains run smoother and quieter, with less vibration and longer maintenance intervals than those in many Western systems. In contrast, the United States is living in an era where high-speed rail remains a theoretical concept in most states. Take California's infamous bullet train project, decades behind schedule, over budget, and still crawling along with basic construction. Why? Because every section of track is fought over, contracted out, and built piecemeal. The US still relies on outdated, manual-intensive track-laying methods that wouldn't look out of place in the 20th century. Meanwhile, China is deploying multiple CPG 500 units in parallel, connecting city after city like it's filling in a jigsaw puzzle. The CPG 500 was instrumental in creating headline-making routes like the Beijing-Shanghai high-speed line and the Lhasa-Ningxi stretch of the Sichuan-Tibet Railway. In regions where weather windows are small, terrain is volatile, and logistics are difficult, this machine shines. It's even been customized for use in extreme altitudes and sub-zero temperatures, making it the backbone of rail expansion in China. Shocking, right? Well, there's a lot more from where that came. Number 5. Bonant self-climbing formwork system. When it comes to conquering the sky, China has never been shy. From megacities like Shanghai and Shenzhen to rapidly transforming second-tier urban hubs, the skyline is a battleground of ambition, and one machine is quietly transforming how those towering giants rise. This is the Bonant self-climbing formwork system, a robotic marvel that has effectively replaced cranes and scaffolding in the construction of modern Chinese skyscrapers. It's not flashy, but it's brutal in its efficiency, revolutionizing how China defies gravity. This automated system works like clockwork, inching its way up the skeleton of a building using hydraulic actuators and steel guides, carrying with it the molds used to pour concrete floor by floor. What used to be a slow, crane-intensive dance with weather delays and safety hazards has now become a vertical assembly line, faster, safer, and more precise. This formwork system literally climbs the structure it's helping to build, offering workers stable platforms at every level without waiting for scaffolding to be dismantled and rebuilt higher. The Bonant system can slash construction time on a high-rise by weeks or even months. Instead of waiting for a tower crane to swing each formwork piece into place, Bonant's modular platforms simply hoist themselves skyward. With minimal crew, lower safety risk, and consistent output, skyscrapers shoot up with a kind of mechanical rhythm that human teams alone simply can't match. This isn't just about speed, it's about control. The Bonant system allows for micro-adjustments in positioning, ensuring that each floor aligns perfectly. This level of accuracy is essential when you're talking about super-tall buildings where even millimeters of misalignment can create massive structural issues down the line. And because the climbing system operates independently of cranes, those cranes are free to handle other logistics, like moving heavy steel beams or facade components. It's a multitasking dream, and one that makes China's rapid vertical expansion look effortless. Now, compare that to the old-school model still used in much of the Western world. In cities like New York, Toronto, or London, skyscraper construction remains reliant on massive tower cranes and manually assembled scaffolding systems. These are slower, riskier, and often heavily delayed due to union labor disputes, supply chain snags, or simply a lack of available crane time. By the time a Western skyscraper reaches the 40th floor, a Bonant-powered structure in China is topping out. And let's talk impact. The Bonant system has already helped shape some of China's most iconic urban landmarks. Whether it's the twisted architectural elegance of the Shanghai Tower, the soaring business cores of Chengdu and Wuhan, or the mind-bending gravity-defying supertalls in Tianjin and Guangzhou, Bonant's influence is everywhere. Its versatility is also key. Unlike traditional climbing systems, Bonant's platforms can be customized to match various building shapes, such as curved, angular, and even asymmetric. That means architects no longer have to limit themselves to what's easiest to build. They can dream up bold, futuristic forms, and Bonant will simply adapt. It turns complexity into a non-issue, giving Chinese developers the confidence to push the envelope without fear of months-long delays. Number 4. XCMG 4000T Crawler Crane. When it comes to lifting the impossible, few machines in the world can even attempt what China's XCMG 4000T crawler crane does on a regular basis. Towering, relentless, and monstrously powerful, this behemoth has earned its place as the king of heavy lifting, not just in Asia, but globally. With an eye-watering lifting capacity of 4,000 tons, the XCMG 4000T isn't just the pride of China's construction industry, it's a statement. Built by Suzhou Construction Machinery Group, one of China's top industrial giants, the XCMG 4000T is not your typical crawler crane. For starters, its sheer lifting ability dwarfs almost every competitor in the West. The closest equivalents, like the Liebherr LR 13000 from Germany, come close, but the XCMG 4000T is engineered with a specific kind of adaptability and modularity that makes it uniquely suited for China's vast and rapidly evolving mega projects. We're talking about reactor domes for nuclear power plants, offshore wind turbine towers taller than skyscrapers, and ultra-heavy prefabricated modules that are simply too massive for traditional cranes. The XCMG 4000T was built with precision-heavy national infrastructure in mind. Nuclear power construction is a prime example. The reactor dome, the thick, reinforced concrete or steel shell that caps a nuclear reactor, can weigh over 1,000 tons. These components not only require surgical placement, but also must be hoisted high above complex existing structures. The 4000T's high hook height, stability, and pinpoint load control make it one of the only cranes in the world capable of handling this task safely and repeatedly. Then there's the wind energy boom. China has invested heavily in both onshore and offshore wind farms, many of which require turbines exceeding 120 meters in height. These aren't just tall, they're heavy. Each segment of a turbine tower, each rotor blade, each nacelle, which is the engine housing on top, all of these need to be lifted several stories into the air and held there while they're precisely attached. Traditional crawler cranes simply cannot manage the scale or the wind load involved. The XCMG 4000T doesn't blink. Where this machine really outclasses its Western counterparts is in deployment flexibility. Despite its size, the crane is modular and can be broken down, transported, and reassembled much faster than similar capacity cranes in the West. Its components are built for China's sprawling logistics networks and can be moved by rail or heavy-haul truck across provinces with military-like coordination. This means that the 4000T is a workhorse, regularly seen in the thick of national-scale projects. And while American infrastructure continues to battle red tape, aging equipment, and underfunded upgrades, China's industrial base is leveraging machines like the XCMG 4000T to build ahead of demand. For example, while the US struggles to modernize its nuclear power sector, with only a handful of new reactors even on the drawing board, China is building entire nuclear parks. And each of those reactors, one by one, has likely been touched by this crawler crane. Another striking feature of the 4000T is its control systems. The XCMG integrates intelligent lifting algorithms, real-time stress monitoring, and fully digital operator consoles. The result is astonishing stability and precision, even under high wind or on uneven terrain. In environments where even a slight misalignment could lead to catastrophic delays or damage, this level of control is priceless. Number 3. WK-12 Walking Bucket Wheel Excavator. Towering over the earth like a moving fortress of steel, the WK-12 Walking Bucket Wheel Excavator is one of China's most awe-inspiring engineering feats. Weighing an astonishing 6,000 tons, this mammoth machine looks like something straight out of a dystopian sci-fi epic. But in China, it's just another day at the mine. The WK-12 isn't just big, it's a full-fledged mobile factory. Its signature feature is the bucket wheel, a rotating array of massive scoops that continuously chew through soil, rock and overburden at a rate of 12,000 cubic meters per hour. That's enough material to fill nearly 5 Olympic-sized swimming pools every single hour. And it doesn't stop for lunch. This machine is made to operate for days, weeks, even months with minimal interruption. It strips away earth with mechanical precision so that underlying resources such as coal, iron, copper and rare earth metals can be accessed. What separates the WK-12 from similar Western machines isn't just scale, it's mobility. This excavator doesn't roll on tracks or tires like conventional machinery. It walks. Yes, literally. It's fitted with massive hydraulic feet that let it walk across rugged terrain. This unique locomotion design allows it to maneuver across unstable mining grounds that would sink or stall most other equipment. It's an engineering solution tailored to China's highly varied mining topography, from soft less to hard rock, proving that brute force isn't enough. Adaptability is key. Western nations do have large bucket wheel excavators. Germany's Bagger 288 and Bagger 293 are famous examples, but machines like the WK-12 are increasingly rare outside China. In the US, for instance, large-scale strip mining is declining due to environmental regulations and shifting energy markets. As a result, there's been little incentive to develop or deploy new generation mega excavators. Meanwhile, China continues to mine not only for domestic industry, but also to maintain control over global resource supply chains, especially in critical sectors like rare earth metals. Machines like the WK-12 are indispensable in this strategy. Number 2. Zoomlion ZC3200NP Crawler Crane. Towering at an astounding 178 meters tall, the Zoomlion ZCC3200NP Crawler Crane has been built for one purpose only: lifting massive components in large-scale projects. As the world faces an increasingly urgent climate crisis, countries are scrambling to adopt renewable energy sources, and China's ZCC3200MP is leading the charge, ensuring that wind farms and other renewable projects reach new heights, literally. With a lifting capacity capable of handling some of the largest components in wind farm installations, this crane isn't just impressive in scale, it's a game changer. The ZCC3200NP has been engineered to handle the massive turbines, which can weigh over 400 tons and have blades that span more than 100 meters in length. These components, critical for harnessing wind energy, require precision and power to transport and assemble, and that's where the Zoomlion Crawler Crane excels. The machine lifts these immense parts and places them with impeccable precision, enabling the construction of wind farms that would otherwise be impossible to build. When compared to cranes in the West, the Zoomlion ZCC3200NP is a benchmark of what's possible when cutting-edge technology meets the growing demand for renewable energy infrastructure. The US and European countries have formidable cranes, like the Terex CC8800-1 or the Liebherr LR 13000, used in the energy and construction sectors. But in terms of capacity, reach and application to renewable energy projects like wind turbines, the ZCC3200MP takes the lead in China. This specific crane has been integral in China's ambitious renewable energy program, which aims to become a global leader in wind and solar power. With China's investment in wind power projects escalating, the ZCC 3200NP is ensuring that the country's green future is built on a foundation of massive, precision-engineered lifting power. This crane also signifies a larger industrial strategy. As part of China's Made in China 2025 initiative, the ZCC 3200NP reflects the nation's ongoing efforts to build and innovate advanced machinery in-house, with minimal reliance on foreign technology. While many Western nations have relied on imports for some of the most advanced construction machinery, China has been aggressively advancing its capabilities in this area, bringing these massive machines into their own manufacturing fold. The ZCC 3200NP is a prime example of China's commitment to not only advancing green energy, but also achieving self-sufficiency in the equipment that makes such progress possible. The crane's construction isn't just about size or lifting capacity, it's about precision and safety. To lift and install a wind turbine's heavy components at dizzying heights demands a level of accuracy that can only be achieved with advanced technologies. The ZCC 3200NP is equipped with state-of-the-art control systems, including real-time monitoring and automation, which ensures that every lift is executed with perfect precision. In addition to its primary role in wind farm installations, this crane has been employed in large-scale construction projects for power plants, industrial facilities, and even major infrastructural projects like bridges, where its lifting power and precision make it invaluable. One of the most striking features of the Zoomlion ZCC 3200NP is its crawler design. Unlike traditional wheeled cranes, the crawler system offers superior stability and mobility, allowing the crane to navigate rough, uneven terrain commonly found in remote wind farm locations. This ability makes it especially suited to install wind turbines in areas where traditional cranes might struggle to reach. Whether it's scaling steep hillsides or working in marshy, unstable environments, the ZCC 3200NP is designed to move without compromising stability, an essential factor when working with wind turbines that require exact placement. Western countries have impressive machinery and heavy lifting capabilities, but they often rely on multiple specialized machines to perform tasks that the Zoomlion ZCC 3200NP handles in one fell swoop. The machine's ability to manage the entire lifting and assembly process of wind turbines with its sheer size, strength, and precision ensures that projects are completed faster and more efficiently, something crucial in a world where every day of delayed installation means lost potential for clean energy generation. Brace yourself for this next one. It's a true shocker. Number 1. Sany SCC 40000A. Sany SCC 40000A. Crane boasts a staggering lifting capacity of 4,000 tons. This machine represents a significant milestone in China's pursuit of becoming a leader in high-end construction machinery. It's not merely the lifting power that sets this crane apart, but the level of sophistication embedded in its design. Featuring a V-type twin lattice boom configuration that can extend up to 120 meters and a maximum lifting moment of 90,000 ton-meters, the SCC 4000A is built to hoist massive components to substantial heights with pinpoint precision and unmatched stability. To ensure it can safely handle such extreme tasks, the crane is outfitted with a 4-crawler, 8-drive walking system. This unique setup provides unparalleled stability and allows the machine to move and adjust positioning on-site with greater flexibility. Further enhancing its lifting capabilities is a double crawler-mounted superlift counterweight trolley that redistributes loads to prevent tipping during maximum reach or height. Transporting such a massive crane is a logistical feat in itself. It must be broken down and carried by 150 trailer units, each hauling approximately 30 tons of components to the construction site. The scale of both its assembly and disassembly underscores just how colossal this machine truly is. Its most notable debut came during a high-stakes operation in northern China, where it successfully erected a massive propylene splitter tower as part of a multi-billion yuan petrochemical initiative. The tower, being the heaviest component in the entire project, demanded a machine with both immense strength and engineering finesse. The SCC-4C2000A delivered on both fronts, showcasing not just brute force, but also reliability in executing delicate maneuvers under challenging conditions. This performance solidified its role not only in petrochemical construction, but also in sectors like nuclear power and offshore wind energy, where the handling of massive, sensitive components is routine. Clearly, China is living in the future, and the Western world has to catch up. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.